recording this meeting.
Perfect. All right, welcome back, guys. Thanks for joining on time. I'm happy to see that. So we're going to go over some top-level concepts to kind of refresh our memory. And I want you guys to ask questions. This stuff is really confusing. A lot of different terms being thrown at you. So if something doesn't make sense, it probably doesn't make sense to another person either. So don't be embarrassed and speak out if you have any questions, and please interrupt me. So first thing I just want to talk about is what's a class and what's an object and how do they relate? So Java's an object-oriented programming language. So essentially, you create kind of this blueprint, which is called a class. So in this example, we have main.java. Main.java has int x equals 5. That's it. So this is kind of your skeleton for your object. So what's a class? You have one class to potentially one-to-many objects. It's just the blueprint for your object. If you want to create an object off of main.java, your main class, how do you do that? I don't like how they do this, but in this example, this is terrible. This is awful. Let's do our own thing here. So we have our public class main, right? Now we're gonna have public class. Let's get rid of this. How about we do this? We have our class object example. There we go, and we'll do this int x equals 5. So let's make it public. So we have two classes. We have our public class main and we have our public class object example. And in object example, int x equals 5. So how do we declare an object off of this class object example? We new it up, so to speak. So object example equals new object example. That's how you create an object off of a class. And now what I can do is print out this x. So system.out.println example.x. So what am I doing? I'm calling the example object and printing out the class attribute x. What is the class attribute x? Well, if we look at our class object example, we can see it has a class attribute x, which is an int, which is just a whole number, and x equals 5. So theoretically, if we run this, we will get some error, but it should print out 5. We need to, so here, let's make this bigger. So it doesn't like that we tried to declare a second class in here because it presumes that this file we have open is called main. So we're just going to declare our class within main. That should get rid of the first error. I hate this. We'll make it static. Don't worry about what static means. This is just an example. And we need to import system. Is that java.system? Over here, it tells us that we cannot find simple system. We cannot find class system. So we need to import system so that it knows what system is. So let's figure out what import we need for system. We need to import java.lang. Java.lang contains the class system. So java.lang, I think that's how you do that. Maybe it's like this.
Yeah, it is absolutely the dot star. You got it.
Hate the syntax. System.out. Sorry about that. So I've been doing this for a long time, and you can see that anytime I need to write something from scratch, I got to work through errors. If you get errors, it is absolutely okay. System.out.println. Come on, give us a 5. There we go, 5. So to recap, we have our public class main. We have our entry point to our program. This method main is our entry point to the program. So when we press run, it's running this method. We declared a class called object example where we have a class attribute int x. We set the class attribute x to 5. What is an int? Int is a whole number store. It's called a primitive variable. And then we declared an object called example of type object example. So your class is your blueprint for your object. How do you declare an object off of a class? Well, you give it the class name, give it the variable name. Your object name is going to be example. And then you say new class name, parentheses, open, close, to call a constructor. And we'll talk about constructors here in a second. And then we have to import java.lang because within java.lang, there is system. You can think of it kind of like that. So we're telling Java that look in the java.lang package for the system class. And then within the system class, we can use it to print out our variable value, which is 5. So that's how objects and classes relate. Let's move on to constructors. So what's a constructor? A constructor is let me put that over there. A constructor is like the first thing that runs when you initialize an object. So you have this class main. When you declare a new instance of main, declaring it makes it an object called myObject. You set x equal to 5. Because you say new main, this main parentheses open close is referencing this constructor main parentheses open close. So let's go back to our editor and let's add a constructor to object example. So to declare a constructor, you say public class name. That's the way you declare constructor. That's the constructor signature. And then we can set x equal to 5. So, oops, I have a bad habit to press Control S. So when we create a new object called example of type object example, it's calling this x equals 5. So now if we run this, cross our fingers we don't get any errors, we should still see 5. So let's talk about multiple constructors. So here I could say object example int x. And then I could set this dot x equal to x. So now we have 2 constructors. How does it know which constructor to call when we declare a new object example object? Well, it knows because when we say new object example, we're specifying which constructor we want to call. We want to call the empty constructor here because we didn't pass anything in. How do we call the second one? What if we want to set x equal to 6? We can pass in a 6, and now it knows that we're calling the object example constructor that takes in an int. So it knows that it looks at our constructors and says, okay, this is an empty constructor, so this isn't applicable because we're passing in an int. So we need to go to this constructor that takes in an int.
Hey, Kusha, what would happen if you made another constructor that also only had one int and did something different?
I don't know. I think you would get an error.
You would get an error. The signature, you'd have a signature collision.
Here, we can try that out.
Yeah.
Let's get through this and then let's try that out. I want to try a few different error scenarios, and that's a good error scenario that you brought up. So how do we know to call this constructor? Well, we need to pass in what signature attributes it requires. So it requires an int x. So pass in a 6. Let's talk about this. What is this? This refers to your class attributes. So how do you differentiate between this int x and this int x? We'll use this. This.x references this x, the class attribute x. And then this x, since it doesn't have a this in front of it, it represents the x being passed in through the object. I'm sorry, through the constructor signature, excuse me. Still get tripped up on terms. So if we run it, we should see that it prints 6. Perfect. So let's do what Stuart was telling us. What if we have two constructors that have the same signature, same constructor signature? This is our constructor signature up here. And then we can do this.x equals y. Probably going to get an error, and it's going to have, like Stuart said, collision. So we can see this error says constructor object example int is already defined in class object example. We already have a constructor that takes in an int. So it's not going to let us do that. And just so we understand the relationship between classes and objects, let's create another object off of object example. Let's call it example 1. And this time, for example 1, we will not pass in anything to the constructor. So it's going to call our default constructor. It's default because it has a empty signature. So we should see that it prints 6 and then it prints 5. And we can see that you have one class declaration, but you can have 1 to infinite object declarations off of that class. Your class is your skeleton for your objects. By the way, I'm not watching chat. Maybe I should be watching chat. I'm so sorry. Please interject. Yes, I will make it more clear when I'm talking about this. I will try to use this more seldomly when I'm talking about the concept this. And I'll try not to throw around the word this when I'm talking about that concept. So is it a runtime error or syntax error when there are two of the same parameter constructors? Great question, Hannah. I'm really glad you asked. So we know it's not a runtime error because it gives us this. Unfortunately, it says run here, but usually there's 2 steps to running a Java program. You compile it, you take this almost English-looking program, and you translate it to something the computer can understand. This is kind of blowing past the whole compilation subject, but essentially we're taking this almost English program and translating it to ones and zeros so the computer can understand it. That's a very simplified way of putting it. So this is a compilation error. It's a syntax error. When we press run, it compiles this. If the compilation is successful, then it runs that compiled class. So in this case, this is a compilation error. It's not going to let us run this program until this constructor, duplicate constructor is removed. Hopefully that made sense. Great question. So, do we already see 5 and 6? Six and 5. Any questions on this before I move on to class methods?
So just to be clear, in the, I don't know what it's called, but the like second kind of like paragraph thing where it says the public static void. So it has the object example where it calls the object with an int, and then the second one is calling the empty one. So
That's right.
that's why the 5 comes after. Okay.
That's exactly right. So this is this public static void main is your entry point to your program. This is called, for now, what we can call it is a method. It's a method, it's a special method that defines the entry point to our program, what it's going to run when you press run. Any other questions? Cool. Awesome. So let's talk about class methods. So we have this main class, public class main, and we have a static void. We have a method called myMethod, which is of type static void. So when you call myMethod, it's going to print out hello world. Let me do it in the editor. It'll be easier to do it in the editor. So what is a class method? Well, let's say we want to change X. We want to set X to a different value. What we do is declare a public method. So in this case, we would do public void set X. And then we pass in an X. The reason it's public is because we want to be able to call set X outside of the class object example. If I did private void set X, and then up here, I did example dot set X 1, it would give me an error. And I think, in fact, we can see that error. It's going to say that set X has private access within object X example. Did not do that. That's awkward. Why didn't it do that? Is it because it's a static class within class main? Did it not save? Yes. So in languages other than Java, methods are like functions. You will probably hear me use method and functions interchangeably. Each object-oriented programming language will use either methods or functions.
Yeah, that's just, it's just something, Java calls them methods, and there are some specifics to a difference between a method and a function. Yeah, that's just how the language, just specifics of the language.
Okay, so I improved this example a little bit. Thank you for the explanation, Stuart. I improved this example a little bit. Object example doesn't live in main anymore. It's declared in its own little context. So now we can get back to what I was saying. We called example.setX. However, setX is private. So you can only use setX within object example. So if we try to use setX outside of object example, it tells us that it has private access within object example. This is called encapsulation. Whether something is public or private, it's called encapsulation. We want to give it the appropriate access level so that we don't accidentally call the method outside of where we would want to call it. So in this case, we want to make this public. And let's actually make setX do something. Let's make, as you guessed, setX set the value of x to what we pass in. So what we would do to make it very clear which x we're referencing, either this x, either the x that I've highlighted, or the class variable x, we use the term this. So when we say this.x, we are referencing the class variable x and not the x we're passing into the method. Set it to x. So again, this.x references the class variable x, while x references the method signature x. So now we can do example.setX1, and then let's get rid of the second object. So we're only talking about one object. And then we can do another print of example.x. So we should see that it's first 6, because we pass in 6. It calls this constructor. This constructor sets x to 6. And then we set x to 1. It calls this method or function. Java calls it a method. We pass in 1, and then we set 1 to our class variable x. So then we should see 6 and 1. Awesome. So, and if we wanted to, we could do an empty constructor. So now we should see 5 and 1, because we call this empty constructor, sets x to 5, and then we set x to 1. I promise we'll get to robots today. I just want to do a little refresher. These are the base concepts, and they're super important. So let's talk a little more about encapsulation. Generally, when you have a class variable, you don't want it to have access. You don't want to have access to this class variable outside of your class. So doing example.x, this is dangerous. What if you're using x to set your robot speed? You could accidentally call x outside of your object, and then you have this wacky bug where your robot goes haywire because you didn't properly encapsulate x. So how do we properly encapsulate x? Well, we can put the private modifier out on it so that int x only has access between, you can only access int x between this and this curly brace. So now if we run it, we should see an error, and this is going to be a runtime error. JK, it's not a runtime error. My mistake. This is a compilation error. X has private access in object EX. So how do we get around this? Well, we can create another class method called getX. Public int getX. So let's talk about this modifier int and this modifier void. Why is this method have int in it, and why does this method have void in it? Void just means you don't return a value. You just do some stuff, and once you get to the end of the method, you're done. When you declare a method and you say that it returns int or double or Boolean, you're saying that you have to return a value by the time you get to the end of that method. So in this case, we would do return this.x. And it would satisfy the condition that it needs to return an int. Here, we don't need to return anything. You would call this function, and it just goes down the list, and you're done. So now we can do example.getX. Example.getX. And since it's a public method, we won't get this private access error. And we can call x within this method because private refers to calling x outside of the class object example. So now we run it, and we should see that our program works like the way it did before. We just encapsulated int x. It's a very, very manual and it's a very manual process now to set the x value and get the x value. You can't haphazardly just say, like, for example, you can't do example.x equals whatever number because it has private access. Now you have to really intentionally say set x huge number. And we're explicitly setting x, there's a little less room for error. So those are class methods, and that's encapsulation. Any questions? Okay, moving on. We talked about modifiers. Modifiers is this public or private designation. Protected is a little more advanced concept as well as default. So we're going to glaze over them for now, and we'll get to it in the future. Class attributes, we talked about class attributes. They're just variables within a class. Oh, it says that right here. You could say that class variables are variables within a class. They're the top level variables within the class. So in this example, our class attribute is private index. And lastly, let's talk about inheritance. This is a tough subject, and I don't know how in depth we're going to get with this, but we'll try our best. So in this example, they have class vehicle. Class vehicle has a class attribute brand. It's protected. Let's imagine protected is public. So we don't have to get into what packages mean. Protected just means that instead of, so private means that you can only have access within the curly braces of the class, right? Protected means that you only have access within that Java package. So since these are in the same file, they will be in the same package. What do I mean by package? If we look at our Romi template, this commands folder is a Java package. It is the FRC robot commands package. You can see that the folder names contribute to your package name. So when we did import java.lang, we're calling the java.lang package, which contains the system class. Okay. So vehicle has a class attribute brand, which is a string, and we set it to forward, and it has a public method called honk. Public and private is like global and local, yes. Sort of, yes. It depends on what language you're talking about. It's not global in the sense that you can access it anywhere, anytime. It's global in the sense that if you declare an object, you can mess with that public variable, while private means sort of like local, where you can only mess with the variable within the class. Sorry about that. So we have class vehicle, and it has this public method honk, and what honk does is prints out toot toot. So now we have a class car. Car extends vehicle, meaning car inherits from vehicle. Vehicle is the superclass, the class being inherited from, and car is a subclass of class vehicle, the class that inherits from another class. How do we know that it inherits? Has this term extends. So now we have this private string model name equals Mustang, and within the car class, I hate that they do this, but they declare a car object, and then they do mycar.honk. How can they call honk on class car when it doesn't have the method honk? Well, since car extends vehicle, you can think of honk living inside of car. it extends the stuff in vehicle. So now when it does mycar.honk, it's going to print out toot toot. And then if we try to print brand, it's going to call this brand up here, because essentially what extending does is takes all the stuff in here and puts it within this and this curly brace of the car class. So we can do mycar.brand, it's going to print out Ford. Then it's, if we print mycar.model name, it's going to call this model name within car. And if you don't believe me, we can press the try it now, press run, and already ran it. Okay, toot toot, and then it says Ford Mustang. Any questions?
So on that, the myfastcar.honk, is that, what is that doing?
It is calling the method honk.
Okay. Right. Okay.
Do you understand how it's calling the method honk?
I do, but then I don't really understand what like the output of that is.
The output is this, is the stuff within the method.
Oh, got it. Okay, got it.
So when you call honk, it goes down the list. Imagine there was a bunch of other stuff in here. These aren't actual programming terms, you might have guessed. But basically when you call a method, it's going down the list and calling every single line. So in this case, you call honk, it does this system.out.println toot toot, which is just printing out toot toot to the console. And then it calls blah, and then it calls blah1 and blah2.
Okay, got it.
Make sense?
Yeah.
Any other questions? It's really important that you guys understand where myfastcar.brand comes from when the car class doesn't have a class variable brand. It comes from this vehicle class, which has this string brand. Okay, so we're going to move on to actual robot programming. Okay, so last we left off, we were working on this drive forward class. Does everyone have this drive forward class? And do y'all's class look like this? Look like my class? Everyone take a second to double check and send me a thumbs up or something in the chat. Awesome, thank you, Ian. Alexa and Hannah?
Yep, looks good.
Awesome, thank you, Stuart and Alexa. It is Control Y, I believe. Yeah, Control Y for redo. Okay, I'm going to assume you're good, Hannah, unless you tell me otherwise. Okay, so let's talk about this drive forward class and kind of refresh our memory with what we were trying to do. So we have this public class drive forward, and it inherits from command base. Drive forward is a subclass of command base. command base being the parent class. Within command base, eventually there are several methods that you can override. Your parent class command base has public void initialize, and it has public void execute, and it has Boolean is finished, and it has void end Boolean interrupted. These class methods are declared within command base. So when we say at override, we're saying we want to use those methods declared in our parent class. I wish I didn't close what we had earlier, but we want to take the methods declared in our parent class command base and override the contents of them. So we're overriding the contents of initialize from command base since it's declared in command base. So what do we want to accomplish with drive forward? Well, we want it to drive forward at a certain speed for a certain amount of time. So what did we end up taking in our class constructor? Well, we took in double speed for how fast we want it to move. We took in double time for what length of time we want it to move at double speed. And then we have to pass in Romi drivetrain. Why do we need to pass in Romi drivetrain? Well, we need to take the object declaration within robot container, this Romi drivetrain object declaration, and we need to pass it around to different parts of our system. The reason for that is you have your robot, right? And it only has 2 motors. So if we declared more than one instance of the object Romi drivetrain, let me back up. If we declared more than one instance of the class Romi drivetrain, meaning we declared multiple objects of type Romi drivetrain, then we have multiple objects referencing these 2 motors. There are 2 motors. We can't have multiple references trying to fight each other for these 2 motors. So we want to use the one reference and go through that one reference to control these 2 motors so that we don't have code fighting to control our hardware. So within our command class, our class drive forward, we pass in the object Romi drivetrain. So why did we choose these class attributes? Well, when we pass in double speed, double time, and drivetrain, it only exists between this first curly brace on line 13 and this last curly brace on line 18. So we want to be able to use speed, time, and drivetrain outside of these 2 curly braces within our class curly braces. How do we do that? Well, we declare class attributes, and then we set the variables that we pass into our constructor signature to our class attributes. We use the term this to reference our class attributes because our class attributes have the same name as our constructor signature values. So when we say this.speed, we know we're referencing the class attribute speed rather than the constructor signature speed. So we set those 3 class attributes to the constructor values that we pass in through the constructor signature. And then we do this add requirements drivetrain. What is add requirements? Well, if you hover over it, it says adds the specified requirements to the command. And you can see it takes subsystem ... requirements. This ... means that you can have more than one requirement. You can have one to many requirements. The reason we do add requirements is that it's so that when we're scheduling commands one over the other, we know what subsystem is using, so we don't have commands fighting each other for that same subsystem. Okay, so then we have this method initialize. What is initialize? Well, initialize, like we wrote in this comment, is called when the command is initially scheduled. So when is the constructor called and when is initialize called? And what is the difference? This is very important to understand. The constructor is called when the object is created. You can create an instance of drive forward and then schedule that command multiple times. You can say drive forward, turn, drive forward, turn. You don't want to create multiple instances of drive forward to do that. You want to reuse that same object so that you're not taking up a bunch of memory. Every time you create an instance of a class or an object, you're taking up a section of your computer or your robot's memory being this pi. We want to use as little memory as possible. So initialize can be called every time we schedule the command, whereas this constructor is only called once when the object is created. So what do we do with an initialize? Well, we set long start time. Long is basically like a double, but it has more decimal points. It's a more accurate double. And we set it to the current system time in milliseconds. System.current time millis. And then we set the arcade drive method on drivetrain, on the drivetrain object to 0,0, meaning 0 forward power. If we hover over this, we can see that takes in two variables, takes in z-axis, x-axis speed, and z-axis rotate. You can think of x-axis speed as power going forward, and z-axis rotate as your robot's rotation axis. We set it to 0, 0, meaning when this command is scheduled, stop the robot. In case we messed up in another command and it was still moving due to another command's actions. And then execute. What does execute do? Execute is called over and over and over again until is finished returns true. It returns a Boolean. Once is finished returns true, execute will no longer loop. What do we do with an execute? Well, we want it to drive at a certain speed, the speed that we passed in every time execute is called. And then is finished, we'll just check if our current time minus the start time is greater than or equal to the time we said we want this command to run. All right, so we're missing one thing. Is finished is called. We've exceeded the time we want this command to run. What's going to happen? Well, it's going to call this end method. Within end, we don't do anything. So what's going to happen? Can someone tell me when our command is finished executing, meaning that current time minus start time is greater than or equal to the time we said this command should run? What should happen and what's going to happen? It's a question for you guys.
Is it just gonna like stop running?
That's what we would like it to do. We would like it to stop running. But we set the speed within execute, and we never stopped it from running. So what do we want to... Go ahead.
It's just not gonna do anything, or it's just gonna keep running, right?
Exactly. It's just going to keep running at the speed we told it to run. We never told it to stop running. So what should we do in end to get this command to stop running? Yes, that's correct, Eden. The robot needs to stop moving, but it's not going to, right? Because execute is called over and over again, and we set arcade drive to this dot speed. Is finished returns true, but then in end, we didn't do anything to stop the robot from driving. So it's just continuously moving at this dot speed.
So is it this dot drivetrain dot arcade drive and then 0, 0?
That's exactly right. That's exactly right. You're both right, Eden and Alexa. Sorry, I'm catching chats very late. You're both correct. You set speed to 0. Why? Because we set arcade drive to this.speed, but we never stopped it. IsFinish just stops execute from being called over and over again. That doesn't mean that arcade drive is going to stop moving at this.speed. We got to explicitly say, let's stop the robot from moving. And that's exactly why we explicitly stop the robot from moving within initialize. Because what if we were not very smart, or we made a mistake and we didn't stop this robot from moving at the end of the command? Well, we'd come into this command with the robot moving, and then we're going to get maybe some unexpected results. Okay, great. So let's wire up drive forward. Let's wire it up. We want to do this within autonomous. So if we go to robotcontainer.java, we can see that it has this class method called public command get autonomous command. And we can see that it says, use this to pass the autonomous command to the main robot class. So let's go to the robot class. We can see that in autonomous init, in autonomous initialize, init stands for initialize, we call robot container, the class we were just in, and we say get autonomous command. And what does get autonomous command do? Well, if we control click, we go to that command, or we go to that method, and it just returns the object example command. So when is autonomous init called? Autonomous init is called whenever you select your autonomous class, or your autonomous, like where it says select teleop, disabled, autonomous. Whenever you select autonomous, whenever your autonomous period is happening, autonomous init is called, and then autonomous periodic is called. What's the difference between autonomous init and autonomous periodic? Well, init is called at the beginning of autonomous, while periodic is called multiple times, just like our execute. It's done over and over and over again until autonomous is over. So right now in autonomous, we're having example command scheduled. An example command does nothing. We go into example command, nothing in initialize, nothing in execute, nothing in end, nothing in is finished. Just takes in a Romi drivetrain subsystem and does absolutely nothing. So what do we need to do in robot container to return our new drive forward class instead of this example command object? I said that wrong. I should have said, what do we need to do to return a drive forward object instead of this currently declared example command object? Can anyone tell me? They do it for you with example command. They declare an instance of example command here. This example command from the package commands. We can just look at how they do this and create an object of drive forward and return that object. We return mauto command here, right? Which is this object, this example commands object. We can just do the same exact thing, except we need to create an object of drive forward. Can someone tell me how to create an object from our drive forward class? Our class is our skeleton for our object.
Is it kind of the same as in the drive forward? It's like the this.drivetrain?
Not necessarily. No. It's so. Let's see. They declare an object of example command here, right? It's called mauto command. We want to mimic this exact line, except instead of example command, we want to create an object of type drive forward. Did that make sense?
Okay. So would it just be private final and then drive forward m underscore
Remember, this is your object name. It can be called rainbows if you wanted to. I recommend against rainbows because you have no idea what the heck rainbows mean. So give it a meaningful name.
right, okay. Could we just call it drive forward?
Yeah, absolutely. Let's call it drive forward. In fact, when we start typing, it's going to suggest drive forward. I really don't know why they do this m underscore thing. I prefer to do it this way. So you're exactly right. So what now?
And then equals new drive forward.
That's exactly right. So drive forward takes in, let me open drive forward to the right. I'm going to put this on. Let me close this. We can see that drive forward takes in some stuff. We can't just say new drive forward, right? Because there is no constructor that takes in nothing. There is no empty constructor here. We have one constructor that takes in 3 things. So can you tell me what I need to do here to take in those 3 things?
Do you just put drivetrain?
So that's one of the inputs is drivetrain.
Oh, okay. Right.
Like for example, let me give you an example that you may make this easier. Joystick requires an int port, and we pass in a 0. That's correct. We need to pass in speed, time, and drivetrain. So how do we do that?
What do we need to like know what we want our speed to be?
Yeah, pick
Or
a
can we
speed.
just okay? Or can we just put like int speed?
You can't put int speed. You have to give it a value. You could do int speed equals. By the way, speed is between -1 and 1. You could do speed equals 0.8.
Nope.
And then
nope,
say.
Nope. Can't do that.
Oh, sorry. Double. Thank you. Thank you, Stuart. You can do that. Or you can do 0.8.
Okay.
So tell me how to proceed.
Okay. So we have our 0.8 for speed.
Sure.
Or yeah, and then what is it for time? Like, what are the
What does time do? What is the use of time within our
like-
drive forward command?
like how long it's gonna run?
Yeah, exactly. The unit of time is a double. So something with a decimal point.
Okay. So can we just
Sorry, it does need to be multiplied by 1,000 because it's time in milliseconds. So if we wanted to do like drive forward for 1 second, that would equal to 1,000 milliseconds. So you need to think of it in milliseconds. Since we're doing this comparison, current time millis in milliseconds. Does that make sense?
Right. Okay. So would we write it as 1 second or would we write it as something milliseconds?
You need to write it as milliseconds since we do this
Okay.
comparison here in milliseconds.
Okay. Then can we do like 1,000 milliseconds?
Sure. So it drives forward for 1,000 milliseconds at 0.8 speed. We need now to pass in our instance of Romi drivetrain. How do we do that?
What's the variable for that? Like, what does that mean?
We need to pass in an object of type Romi drivetrain. You're absolutely right, Eden. It's M Romi drivetrain. And I'll explain why here. We have this object declaration of Romi drivetrain called M Romi drivetrain. here we have this empty shell for Romi drivetrain called drivetrain. We need to pass in an instantiated object, aka line 26 in robot container, called mRomi drivetrain, to make this shell into an actual object. Does that kind of make sense? I explained it very poorly, I think.
Yeah, that kind of makes sense.
Okay. Any questions? I'm going to assume that's no. So now we've created our drive forward object. Very nice job, both of you. But we're not doing anything with that object. It has this squiggly, and if I hover over this squiggly, we can see that it's a warning. The value of the field robot container.driveForward is not used. We want to use it. So right now, if we go back, let me open up robot on the side here. Within autonomous init, it calls this get autonomous command on robot container. What does get autonomous command return right now? Well, it returns mauto command. What is mauto command? Well, we can see up here, it's an object of type example command. So instead of returning, instead of getting example command in line 59 within robot, how do we modify get autonomous command to return our drive forward class? I just set the answer within the question. Exactly right. Return drive forward semicolon. Perfect. Perfect. So now we can go and run this. Let's turn on our robots and put it in autonomous instead of putting it in teleop and see if it drives forward.
I need to grab my robot really quick. I'll be right back.
Okay. Everyone should go and grab their robot and tell me if you were successful. I don't know which side is the front. Just hold it in the air and see which way it goes. So I've connected to my WPI libpi Wi-Fi network. I'm gonna go ahead and press run, which is just F5. So once you run your code, you should see this screen. And let's talk about what this robot state box means. Before we do that, we can just see it run. So if I select autonomous, theoretically it should drive forward. Did not drive forward. It didn't drive forward because it's complaining that I don't have a controller plugged in. Let me get my real controller. What do you mean it doesn't like it? Instead of pressing run, can you try pressing F5? Perfect. It takes a while.
So while we were doing all that, I forgot to like actually update everything in my computer. So what did we do in Drive Forward again?
Here, I can open it up for you. Oh, that's not what I wanted to do. Is that good?
Yes.
Let me move this to my other screen. Eden, did yours work? Can you paste some of that error? What am I doing wrong? Mine is not running. Let me know if you need something, by the way, Alexa, and I'm preventing you from seeing it.
Yeah, can you pull up the robot container?
This is a robot container on the right.
Oh, got it. Okay.
We did.
Oh,
maybe give me a snippet of what it said, maybe like out loud or type it out. Read through the error, see if there is anything human readable that you may understand that may give you a hint of what's going on. Okay, mine's working. For some reason, it doesn't like speeds close to 1. My robot will glitch out if I give it like 0.8 to 1 speed. I always have to give it like 0.5 speed. So you may try that, Eden. Try doing a 0.5 speed for 5 seconds. So 5,000 milliseconds. How's it going, Alexa?
I'm getting 2 errors. One of them
What
is
is it?
on the, so they're both on the line 27 or line 30 for you.
Okay. You want to share your screen?
Yeah. Okay. Yeah.
Okay. Cannot be resolved to a type. So we've run into this error before. Hover over it again. So do you remember what we were supposed to do with when this error comes up? Do you remember what this error means?
I feel like something's not being like defined or like we didn't set up.
Right. Another word for defined is imported. Like Eden said, you got to import it. So if you scroll up real quick before you fix it, you can see that on line 11, it says frc.robot.commands.example command. You've defined the place where example command is written, for example. Shouldn't use the word example. You have to do the same thing for drive forward. So it gives you a little quick fix button. Go hover over it and click on that quick fix button.
This one?
Yeah. And press import drive forward. And you can see on line 11 now you have frc.robot.commands.drive forward. And what does that reference? On your left-hand side, you can see that drive forward lives in the folder commands, which lives in the folder robot, which lives in the folder frc. So everything after Java is kind of the package that your class lives in. Okay, let's go ahead and save this. So now you have a little other squiggly saying that this object you created, it's never used. So what do you need to do here? Remember, we're replacing example command with drive forward.
Does it go in here
No.
then?
Scroll down. Keep going.
Oh.
Online. Yep.
Wait.
You got it.
Is it?
Let me open chat back up. I'm really bad at keeping it up. Yep, that's right.
Okay.
It's yelling at you because you have 2 return statements. It's once you hit a return statement, you're done with the function. I'm sorry, method.
Okay. So does that mean to get rid of this one?
That's exactly right.
Okay.
Because you don't want to return m auto whatever that was. You want to return drive forward.
Right. Okay.
So go ahead and save this. And instead of, well, you can try 0.8. It doesn't work with my robot, but it may work with yours. Go ahead and run this, and theoretically it should run. Do you remember how to run it? It's F5.
Oh, right. Did that do anything?
Yeah, it's doing stuff. You can see in the terminal it's doing stuff.
My dog might start barking if the robot suddenly moves.
Output not updated often enough. Okay, let's see here. Let me take over for sharing, Alexa.
Got it.
Okay. So when you run it, Eden and Alexa, what you guys want to do is make sure, first and foremost, your controller is plugged in. So my controller is plugged into my computer. So eventually this screen should come up. Do both of you have this screen up?
Yep.
Let me make sure chat is up for me. It is not up right now. Hannah, by the way, you haven't really said anything. I don't mean to exclude you. Oh, I didn't mean to stop sharing. You just haven't said anything, so please communicate if you have any questions or if something's not working. So let me know when both of you guys are on the screen, and it should have controller under system joysticks. No worries, happens to the best of us. You saw how much I struggled with errors and how much that I had to do Googling, even though I've done this forever. Everyone.
When we get back in the shop and we're actually working on the robot, and we were talking about this beforehand. We were talking about swerve drive. And it's like, oh, we got, we can just do this swerve drive stuff. It's like, yeah, but it's gonna take like 2 weeks just to hammer out all the bugs and the gotchas and making sure everything's plugged in right. Yeah, that's a lot of robots is that.
Programming as well. A lot of programming is doing the little stuff, trying to debug some stupid error.
What was there's a Wi-Fi password, right?
Yeah, it is something. It is. This is the password. I posted it in chat. Okay, hang tight, Eden. Let Alexa catch up, and we'll do it together. By the way, Eden, those are potentially okay errors. I'm not sure.
Okay, cool.
Do you have the screen up now?
Yes.
Okay, so you're going to want to drag Xbox controller to controller 0 to joystick 0. The reason we want to do that is if we look at robot container, when we declared our joystick object, we said it's going to be on port. We know this 0 means port because if we hover over joystick, the constructor reads final in port. We set the port to 0. So we want to drag our Xbox controller to joystick 0. So once you've done that, you should be able to select autonomous and your robot should start moving.
The 0.8 speed seems to be okay. Or yeah.
So if you wanted to, you can make it go a lot longer. You can make this 10 seconds. So I'm doing my robot. My robot doesn't like 0.8. I have to do 0.5. I'm doing 0.5 speed at 10 seconds. Excuse me. I'm going to save it and run it again. You should see it drive forward for 10 seconds. Eden, did yours run? it closed and your robot didn't move. Did you make sure you're connected to the Wi-Fi? Try turning your robot off and on and reconnecting to the Wi-Fi. Looks like we lost Hannah. While you turn your robot off and on and try again, I'm gonna go grab some water. Let me know how that goes, Eden. How do I let someone in from the waiting room?
I can, let me get it, members. Here she's coming.
Perfect, thank you. Welcome back.
Yay. Also,
Cool.
I forgot to mention that I have to leave at 3:30.
Okay, that's fine. Hopefully we can get Eden running by then and we can just call it quits then. While you wait, I encourage you to play with the constructor parameters of drive forward to make it go at different speeds. You can try negative speeds, see how that reacts, try different times, different lengths of time. Play around with it.
To update it, do we just hit save? Or do we have to like re-pull up the run thing?
You have to rerun it because it compiles it to something your robot can understand. If you just save, the compilation step isn't there. That's why it takes a little while for the screen to come up because it's compiling that code.
Right. Okay.
What would happen if you, in your autonomous, you scheduled 2 of them in a row?
It's a good question.
And does this drive forward code have to be run from autonomous? Could it be run in teleop? Could you have a button that if you pushed it in teleop, it drove forward?
Oh my goodness. Ah. Okay, so it flew off the table. We're cool, we're cool.
Careful.
My dog is mad at me for scaring her, but we're cool.
Those are good questions, Stuart. I assume you want students to answer those questions.
What did you say, Stuart?
I said, what were to happen if you were to in your autonomous code, in your autonomous init, you were to schedule 2 of those. You're to do imautonomous command.schedule and then do it again. Schedule 2 of them in a row. Or what would happen if you assigned imautonomous command.schedule, if you were to push a button in your teleop init, in your teleop code, where if you pushed a button, it would schedule imautonomous command. What would happen? Stuff like that keeps me up at night.
I want you to try at least one of those before we leave, Alexa.
Okay.
Either schedule the command twice, or schedule it within teleop, or I forget the other ones. Step overview thing is working on running right now. Fingers crossed. Okay, perfect.
Wait, so do I just do it in robot container, like we did for drive forward?
Do what?
Like how I schedule another.
So if you look in robot, we set m autonomous command to get autonomous command. So now m autonomous command is set to drive forward. Then we schedule that command. So if you want to schedule the command again with that knowledge, how would you do it?
Do you make another command in robot?
You have your command made. This command references drive forward.
Oh, do you have to import it again, or is it okay since it's already in there?
It's already imported. So what does an import mean? Import just means what it is. Where is m autonomous command? To schedule m autonomous command again, you just do .schedule. You can see that we scheduled m autonomous command here. Same thing, it crashed again. And it gave you that WebSocket disconnected, TCP connection closed, unhandled exception. What does it say in unhandled exception? Does it say anything else other than unhandled exception? By the way, Alexa, I'm just going to give you the answer here. If you wanted to schedule this command twice, you could just call schedule again. So now this command's going to run until it ends, and then it's going to run again until it ends. And then I can run it a third time, or a fourth time, or a fifth time, or a sixth time, or a seventh time.
Yay. That's what I was thinking. Like, I'm in that exact spot right now, so I'm glad that I was close.
Perfect.
And if you were to trigger a button off of this, where if a button was pressed, it would schedule it, it would drive forward. The same thing. It doesn't have to be from autonomous.
Okay, we're getting closer, Eden. What does it say in regards to the problem with execute in drive forward? Okay, null pointer exception. We're getting closer. What is a null pointer exception referring to? Does it give you a line number or a variable it's referencing? Null pointer exception is good. We're getting closer. We just need to understand what the null pointer exception is being thrown off of. Null pointer just means you have a variable that you've created like a shell for the variable, but you didn't actually initialize the variable. It's just a name. It's just a shell. It's null.
So when I like added the schedules and then I started the program, it just did nothing. Is that what's supposed to happen?
Did you press autonomous
Yes.
and you set your joystick
Yes.
and you closed and reran it and everything saved?
Yes.
So there's no little white dot. Like if I press schedule, there's this little white dot. That white dot means it's not saved.
Yeah, I saved everything. And there's no errors. So.
Let's see.
You want me to share my screen?
Let me see if I get the same thing. So I scheduled it twice.
Okay.
Hold on. What happened when you pressed?
Like nothing.
Nothing happened. Did you mess with these numbers maybe?
Which numbers?
On
Oh. No, I don't think so. Let me check. Oops.
Eden, what does it say in reference to null pointer exception? Does it say any variable names? Like, does it say drivetrain maybe, or start time, or time, or speed? Need a little more info than just Java lang null pointer exception. We're getting closer. That first line where it says null pointer exception, it should have some details after null pointer exception. The further down you go after null pointer exception, the more stuff you don't recognize. So try to read the first or second line and see if you see anything that pops out at you that is within your drive forward class, like drivetrain maybe, or arcade drive, or speed, or it should give you a line number at least. See if that, what line number? Something about robot periodic in. Unfortunately, I need a little more information than what you're giving me here. Can you double check that your drive forward class looks like mine and that you didn't accidentally mess something up?
Okay, I have to leave. So.
Okay, bye Alexa. Bye. Thanks for coming. Let me know when you've double checked this drive forward class. You've double checked that, make sure your object looks like mine as well. The first place, what is the first place for the null pointer exception? The very first line, what's the first place? Okay, does it give you a line number? Does it tell you maybe like this line within execute has an issue? The null pointer exception is in this method, I understand. What specifically about this method is throwing the null pointer exception? Okay. So can you try removing the parentheses around this dot speed? So it should just be one parentheses open and close. And then make sure in your constructor you set this dot speed equal to speed. So line 35 should look like this. I'm about to paste it in the chat. Okay. Before the simulation opened, do you have this dot speed defined in your constructor? This dot speed equals speed? Okay. Drivetrain.arcade drive. Okay. In your robot container, you have an object that's of type Romi drivetrain. named mROMI drivetrain that you pass into drive forward at the end of the constructor list. Constructor parameter list, I should say. So within robot container, you should have a object of type ROMI drivetrain named mROMI drivetrain, which equals to new ROMI drivetrain. And then within your drive forward object should pass that mROMI drivetrain into the constructor parameter list. When it says, doesn't look like I have that in drive forward. When you say it doesn't look like you have that in drive forward, I'm not quite clear what you mean by that. Do you have this object declared in robot container? Oops. And does it look like mine? Okay. When it says there's a null pointer exception on line 35, can you see if it's referencing drivetrain, arcade drive, or this.speed? Does it say anything related to that? I really can't help you more without seeing the full error. I'm sorry. So if you can like send it to yourself via Slack from one computer to another, or email it to yourself, or take a picture with your phone and post it in Slack, that'd be really helpful for me. I can't help you more than I've helped you without seeing the error. Thank you. Can you send pics? Oh, she left. Are you still? Oh, she's still here. Can you send me a picture of what your whole drive forward class looks like and your robot container class? Unhandled exception, null pointer exception. Send it in a channel, please. Don't send it in a private message. Or if you're going to send it in a private message, send it with me and Stuart in the private message. Okay, in line 24, you do this dot drivetrain equals arcade drive comma 00. Line 24 should look like this. It should be this dot drivetrain dot arcade drive. And then I can see you got an error when you did that and you created a method on line 27. You need to delete that method, the arcade drive method of type Romi drivetrain. And line 24 needs to look like this, like my line 25. It needs to be this dot drivetrain dot arcade drive 0, 0. The reason for that is that you want to call the arcade drive method on the drivetrain object, which is calling the arcade drive method on the drivetrain class, which is Romi drivetrain. If we open up Romi drivetrain, and I'll open up to the other tab so you can see what you need to replace. You can see that there is a method called arcade drive. We want to call that method instead of creating our own method. You've created your own method on line 27 called arcade drive, and it returns null. So you're gonna get a null pointer exception. So in short, change line 24 to look like my line 25 that I've highlighted and delete the method on line 27. And I think from now on, once we complete a class, I'll paste it in chat just so everyone is on the same page. Perfect. Arcade drive is not defined in drive forward. Arcade drive is on the Romi drivetrain class. So you need to call this .drivetrain.arcade drive whenever you want to reference the arcade drive method. So your line 24 needs to look like this. It needs to be this .drivetrain.arcade drive 0, 0. Okay. Awesome. Glad to hear it. I think that's a good stopping point for today since it's just you. Happy you got it working. Please mess around with it between today's meeting and the next meeting, and we'll pick up from there next time. Thanks for joining. Good work today. All right, Stuart. I'll catch you later if you don't have anything. Stuart? I'm leaving the meeting. Goodbye.